morning friends. After the discussion of energy band and also the valence band and conduction band for the conductor, insulator and also the semiconductor. Now, what is the energy band of silicon and germanium? Because the silicon and germanium crystal behave as a semiconductor. In electronics, the silicon and germanium are most important crystal to form a semiconductor. For that purpose, what is the energy band for the silicon and germanium? For that purpose, first we have to show on that what is the electron configuration for silicon and germanium. Now, for the silicon, atomic number of the silicon is 14 and its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p2. That means the silicon have the atomic number is 14. Therefore, K and L cell are completely filled by the electron, while the M cell is incomplete. In M cell, 3s2 and 3p2 valence electron are in silicon. It means the silicon has the 4 valence electron. 4 valence electron. Again, we are going to discuss about explain the energy level of silicon and germanium containing the N atoms at 0 Kelvin temperature. That means the ideal condition. Because at 0 Kelvin temperature, the silicon and germanium act as perfect insulator. For silicon, the atomic number is 14. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p2. In this electron configuration, the K and L cell are completely filled by the electron, while the M cell is incomplete. In M cell, there are 4 electrons. Therefore, the silicon has the 4 valence electron. While for germanium, the atomic number of germanium is 32 and its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p2. According to this electron configuration, K, L and M cell are completely filled by the electron, while the N cell is incomplete. In N cell, there are the 4 valence electrons because 4s2 and 4p2. Thus, the silicon and germanium both are tetravalent. Silicon and germanium both are the tetravalent, both has the 4 valence electron. Silicon has the 4 valence electron in M cell, while the germanium has the 4 valence electron in N cell. Thus, the silicon and germanium are tetravalent. Frequently, the objective question is asked. The silicon and germanium are blank is given. Trivalent, tetravalent, pentavalent, etc. are given. So, silicon and germanium are tetravalent due to it has the 4 valence electron. Now, we are going to discuss about the energy band or the energy level for the silicon and germanium. Okay. For one atom of silicon and germanium, there are the total 4 electrons in outermost orbit of silicon and germanium atom crystal. Right. The maximum possible number of electrons in the outer orbit is 8. Now, silicon and germanium, each atom of the silicon and germanium has the 4 valence electrons. Now, the maximum possible number of electrons in outermost orbit is 8. Thus, the 4 n valence electron for the crystal containing the N atom in a silicon or germanium crystal, if the N atoms are present, therefore there are total 4 n valence electrons, and there are 8n energy state available for silicon and germanium crystal containing the n atom. Now listen carefully this. Each and every atom of the silicon and germanium has the 4 valence electron. And for this atom in outermost orbit, the maximum possible number of electron is 8. Now for the crystal containing the n atom of silicon or germanium has the 4 valence electron and 8n energy state. 8n energy state. Okay. These 8n energy level can be either from a continuous band or they may be grouped in different bands depending upon the distance between the atom in the crystal. This 8n energy level or the state either form a continuous band or there is these 8n energy levels are divided into the particular group according to the separation between the atom in a given crystal. Here it is not necessary these 8n energy levels are continuous. Sometimes there is the continuous or sometimes there is divided into the different group. There is depends on the separation or the distance between the atoms in the crystal. Okay. In crystal of silicon and germanium, the energy band of 8n state is split into 2 bands separated by the energy gap Eg. For silicon and germanium crystal, this 8n state is divided into the 2 groups separated by the band gap energy Eg. Band gap energy. That is the 8n energy levels are divided into the 4n and 4n. Again, in crystal of the silicon and germanium, the energy band of 8n state is split into 2 bands separated by energy gap Eg. Right? As shown in the figure. So here the 8n energy state is divided into the 2 parts. 4n energy level, while the sum gap between the other 4n energy level. Okay. The lower band is completely filled by the valence electron. The lower band is completely filled by the 4n valence electron at 0 Kelvin temperature. And that is known as the valence band. That is known as the valence band. While the upper band or the upper 4n energy state are completely empty. That is known as the conduction band. Again, the upper conduction band with 4n energy states are completely empty. So that is the valence band and that is the conduction band. Conduction band is completely empty while the valence band is completely filled by the 4n valence electron. 8n energy levels are divided in 2 parts, 4n and 4n. The lower band is completely filled by the valence electron, therefore that is known as the valence band of 4n energy state. While the upper 4n energy state are completely empty, that is known as the conduction band. Okay. Now, the lower energy state of conduction band, that is the different energy state, lower energy state of conduction band is denoted by Ec and highest energy level of valence band is denoted by Ev. Right? Again, the lowest energy state of conduction band is denoted by Ec and upper or the maximum energy state of valence band is Ev. Okay. Above the Ec and below the Ev, there are large number of closely spaced energy levels. above the AC, this way, and below the EV, there are the large number of energy levels, and these energy states are closely spaced energy levels. Right? Okay. Corresponding to the one atom, there are the 4 states in conduction band and 4 energy levels in valence band. Here the n numbers are present, therefore 4 n energy state in conduction band and 4 n energy state in valence band. Okay. The gap between the top of valence band and bottom of the conduction band is known as the energy band gap. Energy band gap with energy Ec. And that is also known as the forbidden gap. That is also known as the forbidden gap. Okay? That is very easy. Only keep in mind that that is not important in exam. But to understand about the p-type semiconductor and n-type semiconductor, it is necessary to know that what is the situation at 0 Kelvin temperature in silicon and germanium crystal. Because the p-type semiconductor and n-type semiconductor are prepared from the silicon and germanium. According to the characteristic of semiconductor, at 0 Kelvin temperature, all the valence electrons are bound in covalent bond. Therefore, the semiconductor is act as a perfect insulator at 0 Kelvin temperature. Right? And as the temperature increases, so covalent bonds are broken. Therefore, the electron becomes the free, and this electron take the part in the conduction. Therefore, the conductivity of semiconductor is increases. How it's happened, we discuss later for intrinsic semiconductor and also in extrinsic semiconductor. Again, what is the energy band for the silicon and germanium? Containing the n atoms at 0 Kelvin temperature. For that purpose, we start our discussion from the electron configuration of silicon and germanium. For silicon, the atomic number is 14. Its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p2. K and L cell are completely filled while the M cell is incomplete. There are the 4 valence electrons in M cell. While for germanium, the atomic number is 32. Its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p2. For germanium, K, L, M cells are completely filled by the electron, while the N cell is incomplete, having the 4 valence electron. Right? Therefore, the both silicon and germanium having the 4 valence electron, therefore they are the tetravalent. Both silicon and germanium are tetravalent. Okay. Now, each atom of the silicon and germanium has the 4 valence electron in outermost orbit. There are the 4 electrons in outermost orbit of every atom of silicon and germanium atom. The maximum possible number of electrons in the outermost orbit is 8. Therefore, for the crystal of the silicon or germanium containing the N atom has the 4n valence electron and 8n energy state. That is corresponding to the 1 electron, 1 atom, 4 valence electron and 8 energy states are available. Now for the crystal of silicon and germanium containing the N atom, they are the 4n valence electron and 8n energy state. These 8n energy level can either form a continuous band or they may be grouped in different bands depending on the distance between the atoms in the crystal. Now these 8n energy states either form a continuous band or these 18 energy levels are split into the different group that is depends on the distance between the atom in the crystal. For germanium and silicon crystal containing the 8n energy state is divided into the two bands. In crystal of the silicon and germanium, the energy band of 8n state is split into two bands separated by the energy gap. Easy. The lower band is completely filled by the valence electron at 0 Kelvin temperature. That is known as the valence band. While the upper point state, completely empty at 0 Kelvin temperature, is known as the conduction band. The lowest energy level of conduction band is EC and highest energy level of valence band is EV. There is a gap between these two bands that is known as the forbidden gap. Clear this thing? Okay. So there is the energy band for the silicon and germanium. Clear this? And after that, on the base of this, we are discussing about what is the energy levels for conductor, insulator and semiconductor.